Section 6.7. Today we're talking about radians. So radians is probably something new to you. A radian is actually another unit of measurement for an angle. So up until now in your math career, you probably only measured angles in degrees. Today we're going to introduce radians to you. So here we have a circle, obviously, and it has a radius r. Right there, right? And we have an angle of rotation. We're calling it theta, the Greek letter, often used for angles. And we have arc AB, which has an arc length of r. So the length of arc AB is the same as the radius of the circle. This is important, okay? Now down below at the bottom, we have the definition of a radian. It says a radian is the measure of a central angle whose intercepted arc is equal to the circle's radius. So the picture of the circle, the diagram above, is actually the definition of a radian. So this measure right here, this theta, is equal to 1 radian. And how do we know? We know because the arc length AB is the same as the length of the radius of the circle. So an important question for us to now ask ourselves is, how many radians are in a full circle? We know there are 360 degrees in a full circle, but how many radians are in a full circle? And this diagram shows us the answer to that question. So it says at the top, each one of these radius arc lengths designates 1 radian. So there are about 6.28 radians in a full circle. So let's look at the circle here. You can see the nice color coordination there. So we have 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, 6 radians, and then we have this piece that's left over is about 0.28 of a radian, right? So 6.28 radians in a full circle. You have discovered that there are approximately 6.28 radians in a circle. In fact, there are exactly 2 pi radians in one circle. This means that there are pi radians in a half of a circle. Therefore, 180 degrees equals pi. And we will use this conversion to convert degrees to radians and vice versa. We're going to convert the following degree measures into radians. So we start with 30 degrees. Well, we're going to take 30 degrees and we're going to multiply it by pi over 180 degrees because that's our new conversion. So we're doing dimensional analysis here, right? The degree units will cancel out and we will be left with radians. So if we multiply here, we get 30 pi over 180. And then we can reduce 30 over 180 to 1/6, and we're left with pi over 6 radians, right? And oftentimes, there's no like symbol for a radian. We would write pi over 6 radians, or we would just write pi over 6. All right, let's go to 45 degrees. So we're going to multiply by our conversion again, pi over 180 degrees. Our degrees are going to cancel out, leaving us with 45 pi over 180, and that reduces to pi over 4 radians. Continuing on, 60 degrees. Okay, so we multiply by pi over 180 again, and now we're left with pi over 3 radians. And then 90 degrees, multiply by our conversion, simplify it, right? And we get pi over 2 radians. So we're taking some key angle measures, 30, 45, 60, 90, and we're converting these into radians. Why are we doing this? To understand this. This is what's called the unit circle, right? And in this unit circle, we have measures in degrees and radians, right? And this is going to become more important as you go along in your math career throughout high school. You may even use radians in physics sometimes. So let's understand this circle a little bit better. Okay, so we're starting over here, right there at that point. And at that point, we have not rotated at all. So we have 0 degrees as our angle, and we have 0 radians, right? So then we rotate to this next line right here, okay? And at that point, we have a 30-degree angle, and we calculated on the previous slide that 30 degrees is pi over 6 radians, right? Here's our 45-degree angle, right, from here to here, and we know that that's pi over 4. Then we have our 60-degree angle, which is pi over 3 radians. Then we have our 90-degree angle, which is pi over 2 radians, right? And that's as far as we went in our conversions. But let's see how this continues around, right? Let's start with a 30-degree angle and see how this makes sense. 30 degrees is pi over 6. 60 degrees would be 2 pi over 6, which of course reduces to pi over 3. 90 degrees would be 3 pi over 6, which of course reduces to pi over 2. 120 degrees would be 4 pi over 6, which reduces to 2 pi over 3. 150 degrees would be 5 pi over 6, which can't be reduced. 180 degrees would be 6 pi over 6, which reduces to pi. 210 degrees is 7 pi over 6, which does not reduce. 240 degrees is 8 pi over 6, which reduces to 4 pi over 3. 270 degrees is 9 pi over 6, which reduces to 3 pi over 2. 300 degrees, 10 pi over 6, which reduces to 5 pi over 3. 330 degrees, 11 pi over 6, which does not reduce. And finally, 360 degrees, which would be 12 pi over 6, which reduces to 2 pi. So if we go around counting in these 30-degree increments, or these pi over 6 radian increments, you can see how we can get all of those different angles in radians. Now let's look at it a little bit differently. Let's look at it from the 45-degree angle, right? We know 45 degrees is pi over 4. Well, let's double it. 90 degrees would be 2 pi over 4, which reduces to pi over 2. 135 degrees would be 3 pi over 4, which does not reduce. 180 degrees would be 4 pi over 4, which reduces to pi. 225 degrees reduces to 5 pi over 4, which does not reduce. 270 degrees reduces to 6 pi over 4, which reduces to 3 pi over 2. 315 degrees is 7 pi over 4, which does not reduce. And 360 degrees is 8 pi over 4, which reduces to 2 pi. Now let's go by 60-degree increments. Pi over 3, 2 pi over 3, 3 pi over 3, which reduces to pi, 4 pi over 3, 5 pi over 3, 6 pi over 3, which reduces to 2 pi. And then finally, let's go by 90-degree increments. 90 degrees, we converted it to pi over 2. Another 90 degrees is 2 pi over 2, or just pi. Then we have 3 pi over 2. Then we have 4 pi over 2, which reduces to 2 pi. So you can see that understanding this circle does not mean memorizing everything, right? It really means understanding these key angles, which we converted into radians, and then being able to count around the circle in the different increments.